Today we're going to make a mod for ZX Spectrum, which is a minimap, which just plugs in the back, and it's going to give us a minimap for the game Attic Attack. Or is that Attic Attack? When I mention mods like this, like the Rumble Pack and the minimap, people tend to assume that you have to modify the game code somehow in order to achieve it, but that's not true. This is totally passive. You don't need to modify the game code, which makes this kind of really accessible. You can come up with any add-ons that you can think of, really. The sky's the limit, and I'm going to show you how it works and how I achieved it in this video. Attic Attack is this legendary ZX Spectrum game made by Tim and Chris Stamper and published by Ultimate. The game takes place inside a giant castle, throughout which there are 3 key segments distributed which you need to get to open the final door and escape the castle. As you explore the castle, you'll find various colour keys which let you go through various colour doors. You'll explore multiple levels and something like 150 different rooms trying to find these 3 key segments, all the time avoiding monsters and various big baddies such as Frankenstein and Dracula. If you're lucky enough or skilled enough to find all 3 segments of the key without dying, you have to arrange them into the right order within your inventory to make up the final key, and you can finally escape unceremoniously to the outside world. And how are we going to do that? We're going to use the Happy Little Diode Specduino interface. This is a wonderful little interface, if I may say so myself. These boards are manufactured, you guessed it, by this video's sponsor, PCBWay. PCBWay make all my prototype boards, including this new UV mod board for the ZX Spectrum, and they also do 3D printing, such as this ZX printed drive belt. Wow. And check this out, they will assemble your tiny prototypes too. And don't miss it, there's an assembly service promotion on right now, so go and check out PCBWay. And as I always say, don't forget to look at the shared project pages for some inspiration on what you might want to build or design next. All of these can be ordered directly from PCBWay, and doing so supports the creator. Anyway, back to this. As you may be able to tell, it fits into the back of the ZX Spectrum on the edge connector. It contains one microcontroller, which is an ATmega32U4. The microcontroller has a bit of latching hardware around it for latching certain information, and we have some pins on there which give you access to some of the I/O pins on the microcontroller. So what's it latching? It's latching the address and the data bus whenever it detects that there's a memory write operation happening inside the ZX Spectrum. Just to explain a little bit further, this is what the guts of a 48K Spectrum looks like. The area down here in the bottom left is memory, and that contains the screen memory, which is all of the information that's being displayed on the screen at one time. So that's where all the pixels are and what colour those pixels are. This area of memory also just contains more space for more stuff, as in code and variables and things like that. These 8 chips on the middle bottom right are even more memory. We sometimes call it the upper memory, or we always call it that, and generally within all of this memory, here's what we can find. We can find the screen memory, which we've already described, the game code itself, so the entire code for Attic Attack will be inside the memory somewhere, the system variables, which the CPU is using and stuff like that, the game's variables, and some other stuff which I don't pretend to understand. What we're super interested in is the game variables. The game has to keep track of things like your score, your player position, your player's health, times, things like that, and if we listen to that information as it's being written to those memory locations in which they're stored, we can react to that information. In a game like Attic Attack, where you're moving from room to room, it's a pretty good bet that there's going to be a variable somewhere in RAM which is maintaining the current room's ID or number or something like that. Similarly, the player's position on the screen is very likely to be stored somewhere in memory, and all we need to check that is the game's code. Ideally something disassembled with comments, and people have done that for these old games, and there is a disassembly out there for Attic Attack. So with that in hand, we can very easily, I think, find a memory location which is storing the room ID and the player position. Just to cement in the idea, let's look at the ZX Spectrum again, and we'll take a look at the upper memory. Let's guess that the room ID is in there. There will be a byte of data in here, or at least one byte of data, which contains the current room ID. And when our player enters a new room, the CPU is going to receive an instruction from the game code to write the new room ID to that address location where we have room ID saved. So in this particular example, we might get the value 10 stored in that memory location. Now at this exact precise moment, just a millisecond or so, the edge connector, which contains the data bus and the address bus, will be populated with the room ID address and the value 10 on the data bus. And this is where our peripheral comes in, which has its own memory within the microcontroller, and in there we will save the value 10. And now we have that to hand, so we can write our little Arduino sketch and do whatever we want with that information. And hopefully the peripheral will catch every single update of that address location, so we always catch a room change. We can apply the exact same logic to the player location, and we have all the information we need to construct a minimap. So this was the initial idea, was that we would have our peripheral sniffing the address bus and data bus, and it would use the output pins of the 80 mega microcontroller to drive this little TFT screen. So this is the screen that we're going to use. I didn't put a whole lot of thought into the screen, I just wanted to get one that was the right size for what I wanted to do. So I've gone for this 3.5 inch TFT. It works over SPI, which we'll talk about a bit more, and it's 480 by 320 pixels. It's actually a touchscreen, which we won't be using for this project, but I can see how it could be useful for future projects. Unfortunately, the 80 mega microcontroller works at 5 volt logic level, and the TFT screen works at 3.3 volt logic level, so we need a level shifter in between, and that's this thing. And what this will do is it will translate the 5 volt signals from the 80 mega chip, basically the Arduino, to 3.3 volts, so we don't frazzle the screen, and it will do so very quickly. It will not add any significant delay, and everything should work just right. The SD card slot on the back of the TFT screen has its own header over here, so I'm going to solder these little header pins on, and we should be able to start testing. So here's the setup. We have the interface on the left hand side, which will obviously be plugged into a ZX Spectrum, level shifter in the middle, and our TFT screen with an SD card reader on the right hand side. The idea is to load the SD card with images of the game map, the rooms, and we can load those in depending on where the player is in the game to construct a minimap. Let's build this thing. So having hooked up the SPI pins from the 80 mega through the level shifter into the screen and tinkering with wiring a little bit to get it to work, I was able to get the screen to show some stuff. So here's a little sketch which draws flowers using a library which I downloaded for the screen. And as you can see, it's a little bit slow, and I'm a little bit worried about how slowly it's going to load an entire map tile into a minimap. The reason it's so slow is we're using a serial interface SPI, so all of the data going to the screen is going over essentially one wire. I know it's a 4-wire interface, but the data goes over one wire in a string of 1s and 0s. Now for each pixel, depending on the color format you use, you might be sending 2 or 3 bytes per pixel. And for a 480 by 320 screen, it's even 2 bytes per pixel, you need to send 2.5 million bits of information over that serial interface to fill that entire screen. Add in the overheads of reading the image file from the SD card and trying to fill the whole screen, and well, this is what you get. It's taking many seconds to fill the screen. Now this isn't optimized code, it's just enough to show me that this isn't the way to go with this project, obviously, because the game moves so quickly, you couldn't really deal with this. Even if you could half this time or quarter it, it's just not fast enough. So we're going to need a better solution, and I think I have just the answer. So, when our peripheral picks up the room number and the player position, rather than process it internally, it will simply fire it off on a serial bus over to a Raspberry Pi Pico. Yes, enter the RP2040 microcontroller, and that will in turn act as our graphics card to drive the TFT screen. I'm not using a Pico 2 because I have a drawer full of Pico 1s. Alright, here's our Pico. Actually, it's a Pico W. It's got a Wi-Fi module on it, which we don't need to use. I've stuffed it into this breadboard and we can start hooking something up. I've got another couple of mini breadboards for each side of the TFT screen, one for the screen and one for the SD card slot. Well, fast forward a little bit and it was still too slow using the Raspberry Pi to read the image files from the SD card. I even tried putting the image files directly onto the flash memory inside the Pico, and it was still too slow, really. Not the best solution. So I did think a minimap generally isn't a copy-paste image of the whole map in the game, just shrunk down onto the minimap. It's normally more geometrical or just boxes or simplified little objects like that. So I've decided to go down a different route and try and draw a minimap using vectors and rectangles and things, based on the map of the game, because we have the room number, we know the grid, we have pictures of the whole map that people have drawn that. You can find them online. We should be able to reconstruct it in simple shapes, and that should make quite a nice little mini map. I think something quite simple and easy to look at, easy to glance at, easy to use. So fast forward to a live stream the other day when we were working on this together, and I'll show you how we were getting on. So here we are in the live stream, and as you can see, we're fiddling with the breadboards, trying to get the prototype down onto one breadboard in between the peripheral and the TFT screen. I've got a prototype code working here, which is drawing a minimap, which works quite well, and I'll show you now how it looks. Okay, so this was the first working prototype, and as you can see, it's drawing the minimap, which is representative of the rooms around you on that floor in the castle, take my word for it. And it's drawing the player as a little white dot just in the middle of each room. So at this point, the peripheral is only detecting the room ID, and it's sending that over to the Pi, which is using it to draw the minimap and draw the player just in the middle of the room for now. We'll add the player position next. Alright, so at this point we've got the player position working and everything seems to be pretty good. The only bugs that we were finding, we were kind of working on this together in the live stream, were with the grid references of the rooms on the floors. Sometimes you could go outside the bounds of what the engine is expecting and it would get into a redraw cycle, and sometimes the rooms weren't quite drawn on the right level or with the right colours, and that was just down to the map data matrix which is stored on the Pico. I'm taking this thing to Retrofest this weekend down in Swindon, so see you there if you can make it. And obviously I don't want this running on a breadboard, because something will go wrong and I'll end up trying to rebuild the thing while I'm there. So here we are building it into a project box, soldering everything up, so hopefully nothing gets knocked out of place and nothing can possibly go wrong. So we're going with hot glue to hold everything in place, because I can probably quite easily remove this if I just warm it up in the future, and I can repurpose everything. I had to have 2 attempts at this because I stuck the Raspberry Pi Pico down in a place where I couldn't get the USB lead into it to do further development before the weekend and beyond. So here we are, after a bit of rework, I've got my little display project box ready to go. I just need to do a bit more tweaking and debugging with the code, and we'll have a working minimap. So here's a little quick tour of the code in case you're interested. This is what's running on the 18 mega chip, and this is inside our interrupt routine, which executes whenever it detects a memory write. So if the address is 60049, that's decimal, that is where the room ID is stored in the game Attic Attack. So then we set some flags that we're ready to send that information to the Pico, and then in the loop we handle that serial communication. We also have addresses 60051 and 52, which are the player's positions in X and Y. I've had to do a bit of cleverness to get this to work, because the player position is written in X and Y immediately one after the other inside the game code, and the 80 mega is just not fast enough to catch both of them, so I'm alternating which one we're listening for each time with a little bit of debounce in between, and then we get the player position, and that gets sent again over serial. Over here, this is what we have on the Pico. First of all, there's a library called map data, which contains a matrix of rooms information. So each room has an ID, and each room has a grid position on its floor in X and Y. Also has a code which represents its color, and this character tells the Pico what shape the room should be. And then the positions of the doors in this little array structure. And here we have the floor that the room is in. I've had to be a little bit clever with the stairwells. It will draw each stairwell as its own floor, and if they're all on the same floor in here, it just draws them on top of each other. The main code is quite long and involved. AI has helped me with a lot of this. I'm not going to hide that fact. It has this bit-based list of characters that it draws to draw the Attic Attack logo and the names of the floors, which works quite well. And it will write the name of the floor at the bottom, as you've seen. And it does a whole load of clever stuff to draw the minimap and update it if the player walks off the edge of the minimap. It's also listening constantly for packets of information coming from the 80 mega. So this is the result so far. I think it's working quite well. It's drawing the rooms in the correct shapes and in the correct layout. We've ironed out quite a few bugs with it. It's drawing the doors in the right place, and it's drawing the trapdoors in the right place. I've added a nice little rainbow in the corner that you can see for the ZX Spectrum style. That's a nice touch. And I've optimized it a little bit. You'll notice it's not redrawing the whole screen when you change, when the minimap scrolls. It's only updating the minimap part, which I think works quite well. There are lots of improvements that could be made, and also I think I've reached the limit of what the 80 mega chip can achieve here, because I'm tracking the room ID and the player position and the player health. So there's actually a rumble pack I've implemented as well. There's another video on that you can go and see. And in this demo, the rumble pack is also working. And because it's tracking so many things and the 80 mega is so limited, it does miss the occasional bit of information. So sometimes you might find the room doesn't update, or it misses a vibration if you take some damage. That's going to be resolved in future when we move to an entirely Raspberry Pi Pico or RP, I think 2350B based solution that I'm going to start breadboarding up quite soon. But this will do for now, and if you want to mess around with it, then come down to Retrofest in Swindon this weekend, and I'll see you there. I'm there both days, and I'll have this and a couple of other gadgets, depending how much space we've got to show off. So I hope to see you there, and thanks for checking out this video, and I'll catch you in the next one. Good eye if you've noticed this. I've just noticed it while editing, but the minimap isn't clearing out entirely within the border. I can see the remnants of the old doors there in one line of pixels, so I'll fix that too.